You know that swimming in water during a lightning storm is a bad idea. You might get electrocuted. So why don't all the fish in the water also get zapped? Here to answer this question is Professor Gerald Audette.
Okay, we've all heard that swimming outdoors during a thunder and lightning storm, big no-no. That's because a typical lightning flash measures around 300 million volts, more than enough to kill you. And when lightning strikes water, the electrical current travels quickly through it. So why is it that we don't see tons of fish floating on top of the water dead after a lightning strike? It'd make fishing a lot easier. Well, the answer lies in understanding how water conducts electricity. How fast and how far an electric current travels depends on the water's electrical conductivity, or its ability to conduct that electric charge. The thing is, pure water is actually a really poor conductor. But if it has salts and minerals, it has ions. And these ions carry electrical charges. Ions are atoms or molecules that have a negative or a positive charge because they don't have an equal number of electrons and protons to cancel each other out. They're created naturally when salts, like sodium chloride, or other minerals are dissolved in water. Now, because ions are free to move around in the water, they can conduct an electrical current. And water with more ions, or salts, seawater for example, is a much better conductor than something with a whole lot less, like distilled water. The thing is, though, is that when the lightning strikes the surface, the current's going to travel in all directions, but it's mostly going to travel along the surface. It doesn't have to travel too deep. And as it spreads farther and farther out, the energy dissipates, and the current's completely gone. So, fish swimming deep below the surface are not really impacted. Same with fish swimming near the surface, but really far away. But if a fish is swimming right near the surface, right near that lightning strike, it could get zapped.